At 15 billion miles, Voyager's telemetry suddenly turned to gibberish. Spikes in plasma, scrambled attitude data, and a mystery that made NASA scramble. Was it the heliopause acting up, a failing onboard computer, or something else rewriting our models of the sun's edge? We'll trace the data, the quick fixes, and the real fallout. Let's dive right in. The moment NASA realized something was wrong with Voyager, it wasn't a headline. It was a quiet moment of disbelief. A string of unreadable numbers appeared on the monitors, replacing decades of perfectly stable telemetry. For a mission that had been a model of precision for nearly half a century, that single anomaly was enough to make engineers stop talking mid-sentence. Voyager was nearly 15 billion miles away, in a region of space no human had ever reached. Its faint signal, just a whisper of radio energy, traveled through the darkness for almost a full day before arriving at Earth. When scientists looked closer, they found that the probe was reporting impossible data about its own orientation. It seemed to believe it was spinning wildly, yet somehow its antenna still pointed directly toward home. If that had changed, we wouldn't be hearing from it at all. That contradiction was chilling. Everything seemed normal, and yet completely wrong. NASA's engineers began to suspect the issue lay in one of the oldest parts of Voyager's brain, the Attitude and Articulation Control System, or AACS. This little computer controls the spacecraft's posture, adjusting tiny thrusters to keep its antenna aligned with Earth. Without it, Voyager would fall silent forever. But how could a computer that had worked flawlessly for 45 years suddenly go astray? Radiation, aging circuits, a memory fault. They couldn't send a repair crew. All they had were hours of patience and decades of experience. Through the slow rhythm of data transmissions, engineers pieced the puzzle together. It turned out that the spacecraft had quietly switched to using an old, faulty memory section that hadn't been touched since the early 1980s. A digital ghost buried deep inside the system. It wasn't that Voyager had lost its mind. It was simply speaking through a broken channel. So they wrote a single command, a short message sent across billions of miles. Use the primary computer again. And then they waited. 22 hours of silence. Then a faint tone returned, steady and clear. Voyager had corrected itself. After nearly half a century in space, it still listened. That moment was more than technical success. It was emotional. Every scientist in the control room knew what it meant. The oldest explorer humanity ever launched was still alive, still thinking, still sending back knowledge from the frontier. But that frontier, the edge of the solar system, isn't what we once thought it was. When Voyager crossed the boundary of the sun's influence, scientists expected a sharp transition, a line marking the end of the solar wind and the beginning of the interstellar medium. Instead, they found something far more complex. The data revealed a turbulent, layered region filled with rippling magnetic fields and bursts of plasma. What had once been imagined as a smooth bubble turned out to be more like a living ocean, churning, fluctuating, reshaping itself with every solar cycle. Voyager detected waves of magnetic pressure, stacked like rings in water. These waves are born from the sun's magnetic field, which flips every 11 years. As they move outward, they collide and compress, forming enormous magnetic bubbles that dance along the solar system's edge. The spacecraft had quite literally mapped the heartbeat of our star, still faintly pulsing billions of miles away. Yet something didn't fit. Both Voyager 1 and Voyager 2 crossed this so-called edge at roughly the same distance, about 120 astronomical units from the sun, even though the sun's activity was at completely different stages of its cycle. By every theoretical model, that boundary should have expanded or contracted. But it didn't. Then came the biggest surprise. As Voyager passed beyond the heliopause, the plasma density around it suddenly spiked by a factor of 80. In simple terms, the spacecraft entered a region far denser than expected, a space filled with charged particles left behind by ancient supernovae. The interstellar medium wasn't empty. It was humming. Voyager's instruments even captured this hum, faint, rhythmic oscillations, like a cosmic whisper. That sound told us that space itself isn't silent. It vibrates with energy, memory, and motion. Every reading forced scientists to rethink their understanding of the solar system's limits. The sun's magnetic field doesn't simply stop. It merges, twists, and connects with the galactic field beyond. Our solar system isn't a bubble. It's a living, breathing structure woven into the galaxy itself. And yet, while Voyager continues to teach us about this boundary, its power is fading. The tiny generators that convert heat from plutonium into electricity grow weaker each year. The mission team must make difficult choices, which instruments to keep alive and which to shut down forever. One by one, the sensors that once uncovered Jupiter's storms and Saturn's rings are going dark. Soon, only the most essential instruments will remain, measuring plasma waves, magnetic fields, and cosmic rays. It's not just science, it's an act of endurance, keeping a 47-year-old explorer alive in a place no signal was ever meant to reach. Every command sent to Voyager is a bet against time. Every faint reply is proof that we haven't lost connection with our farthest ambassador. But beyond the data and the silence, there's a deeper truth here. Voyager isn't only mapping space, it's mapping the limits of human persistence. It shows what can happen when a generation builds something meant to outlive them, something that keeps asking questions even after the builders are gone. When NASA received the first clear signal after months of confusion, it wasn't just relief. It was a reminder that exploration doesn't end when a mission goes off script. Sometimes the most important discoveries begin with a glitch, because that glitch led us to realize that the edge of our solar system isn't a line you can cross. It's a region of transition, a blending of our sun's magnetic breath with the galaxy's eternal current. Voyager didn't just survive it, it revealed it. And through those faint signals, through every delayed packet of binary code, we're still learning how vast, how unpredictable, and how connected our cosmic neighborhood really is. As Voyager drifts further into the interstellar medium, its story reminds us why space exploration matters. It's not about the hardware or even the discoveries themselves. It's about the mindset that built it. The belief that even an 8-track tape recorder from the 1970s can carry humanity's voice across the stars, and that curiosity is stronger than time. Voyager continues to travel, slowly, silently, toward a future it will never see. But the lessons it sends back tell us something profound. That the edge of our solar system is not an end, but a beginning. A bridge between the world we know and the vast unknown beyond. Even now, Voyager keeps moving, silent, fragile, and unstoppable. Every second it travels deeper into the unknown, still whispering data across 15 billion miles of darkness. One day soon, that signal will fade. But when it does, it won't mean the end. It'll mean humanity has officially left a trace among the stars. And maybe that's the real story. Not just what Voyager found, but what it proved. That even with outdated tools and fading power, human curiosity can outlast time itself. So, what do you think? Will we ever hear from Voyager again? Or will it become the universe's eternal message in a bottle? Tell us your thoughts below. If you enjoyed this journey, make sure to like, comment, and subscribe to Galactic Breaking News for more stories that go beyond the edge. And don't forget to turn on notifications, because the next discovery might already be on its way. For months, Voyager 1, humanity's farthest spacecraft, stopped talking. NASA feared its greatest mission was over. Then, against all odds, a faint signal returned. But what it carried wasn't what anyone expected. Was this a simple fix, or did something out there wake Voyager up? What happened next didn't just restore contact, it may have saved NASA's most legendary mission. Let's dive right in. When NASA lost contact with Voyager 1, silence filled the control room. For decades, this tiny spacecraft had whispered to Earth from beyond the solar system, a faint heartbeat traveling more than 15 billion miles through the darkness. Then suddenly that heartbeat stopped. At first, no one wanted to believe it. Voyager 1 wasn't just a machine, it was humanity's oldest explorer, the farthest reach of our hands into the unknown. When it went quiet, it felt like a piece of us had disappeared with it. But behind that silence, something unusual was happening. The signals that had once carried clear scientific data started to arrive in strange, precise patterns. Not random static, but structured noise. It was too clean to dismiss as chaos. Engineers thought it might be a software glitch, maybe a hardware failure. Yet deep down, a question hung in the air. What if this isn't a malfunction, but a message from something out there? Voyager 1 was built in the 1970s, its computer memory smaller than the image file of a single smartphone photo. And now, in late 2023, that ancient hardware had to survive cosmic radiation, cold, and isolation beyond the sun's protection. NASA engineers soon pinpointed the problem. The spacecraft's flight data subsystem, its brain, had developed a corrupted section of memory. Just 3% of it was damaged, but it was enough to stop Voyager from sending any readable data back home. It was like trying to fix a typewriter that's floating 15 billion miles away. No physical repair, no access. Every command took 22 hours to arrive, and another 22 hours for the response. Every attempt was a 2-day gamble. And yet, the team refused to give up. They studied the original design documents, pages scanned from yellowed binders written half a century ago. Then they crafted a plan that seemed almost impossible: to move critical code away from the damaged chip, rewriting Voyager's operating system remotely, by hand. For days, the engineers worked line by line, reprogramming a spacecraft that hadn't been designed to be reprogrammed. They divided the code into fragments and tucked them into surviving memory banks, adjusting every pointer and reference manually. It was a quiet act of human defiance, not just against failure, but against time itself. On April 20th, 2024, a faint whisper reached Earth. Voyager 1 was alive. The first decoded signals didn't make sense. Voltage readings shifted, plasma densities fluctuated, and magnetic fields pulsed in perfect rhythm, as if something around the spacecraft was resonating. NASA scientists double-checked the data, assuming it was an artifact of corrupted code. But the patterns were consistent. They weren't random noise. Something in the interstellar medium, the thin plasma between stars, was changing. What Voyager detected could have been the signature of a dense boundary, a ripple in the interstellar plasma, or even the distant echo of a cosmic shock wave. NASA didn't claim it was alien or supernatural.